What's up, pre-calculus students? Let's do a full practice test. Your goal is to do the multiple choice part before you take the multiple choice test next class, and then the free response before you take free response test the following class. So let's do it. 28, no calculator questions, and then, I don't know, 12 calculator questions. 28 questions, 1 hour and 20 minutes. Time is not going to be an issue like it is on other AP exams. Okay. Starting off from 1 to 3, we are decreasing concave up. So we are decreasing at an increasing rate. Concave down, we should see the rates of change decreasing. So I'm going to just look at the rates of change, and I'm going to see, are they decreasing? No. These are going from +1, +2, +4, +4, +2, -2, -4. These are decreasing. If you look at the second differences, they're going to be negative.
And you know the last problem you're saying was like
Ooh. This is good. This is a good question. H inverse, the inverse of H. The point 32 is on the graph of G. So watch this. H of 3 is equal to 2G of 3 plus 3. H of 3 equals G of 3 is -2. H of 3 is equal to -1. If H of 3 is equal to -1, then H inverse of -1 is equal to 3. You kind of had to figure that out because this was a point on G and H was the transformations of G. You kind of had to plug in 3, work from there. Good question. Log properties. Addition is multiplication. E to the power. What's that little guy there? I don't know. To get rid of the natural log, divide by 6. Okay, the rate that water pours into the tank varies in such a way that the depth of the water increases at a constant rate with respect to time.
Oh, no, you beat me to it.
The depth of the water inside the tank increases at a constant rate. So the water's got to be pouring in at a slower rate earlier because it's skinnier. And then the water's got to be pouring in at a faster rate later. So that it's increasing at a constant rate. I don't know if I'm overthinking it. You can kind of see that the depth of the water would be increasing at a decreasing rate if the volume getting poured in was constant. But since the depth of the water is increasing at a constant rate, so the depth we would assume is going like this. That's if the volume of the water being poured in, like the faucet is turned on and left still. It's like we are increasing or we're No, we're increasing the faucet and how much it's open. So this is not true. They changed the situation so that the depth of the water is increasing on the constant rate. For that to occur, so that we're not having the depth increase faster, we need to pour in water slower earlier and then faster later. That's a good question. Oh, we're going volume versus depth. So yeah, if the depth is small, I need to pour in less water. As the depth gets bigger, I need to pour in more water so that my depth stays constant. So this is my guess. I don't have to do the whole guy. I notice like it's going to be either C or D. It's got the 1, 5, 10, 10, 5, 1, with one difference being like the minus and the plus, the minus and the plus. This is a minus and a minus and a plus and a minus. And what I know is that B, A is X, B is negative 4Y. So if I were going to take B to an even power, say squared, it would turn into a positive 16y squared. This is 4y squared, but it would change into a positive 16y squared. If it was negative 4y cubed, it would retain its negativeness. That's good. But then to the fourth, it would change back into a positive. So it's C. Let's say you didn't want to work it out that way. You wanted to actually do the calculations. This is a plus b to the 0. This is a plus b to the first, squared, cubed, fourth, fifth. Oops. Which is just as we expected. This is a to the fifth, a to the fourth, b to the first, a cubed, b squared. Pluses in between everything, but the cube, the square part is where we're going to change. We're going to square negative 4y. It becomes a positive. We see that plus there. Oh, great. So key to rational inequalities is to have all your zeros down. Pay attention to multiplicities like normal. I'm not going to sketch. I'm rather going to just do a sign analysis. Now I do know, and I could sketch if I wanted to. This is a vertical asymptote versus these are zeros. I can see this multiplicity is 2, so the sign of this factor is not going to change to the left and right of 3. But the other multiplicities are 1, so the signs will change. If I plugged in something like, 10, I'd have a negative, positive, positive, positive. So we'd have a negative. I would change signs at 5. I would not change signs at 3, bounce off of 3. But I would change signs at negative 2. We want greater than or equal to 0, so that will include 3, go to 5, not include 5. That's that. If you wanted to sketch, you would see this would be a vertical asymptote. So to the left of 5, we'd go towards positive infinity. To the right of 5, negative infinity. We would have end behavior like y equals negative x. So I would go down to there. I would bounce off this 0 here. I would pass through this 0 here. Oh, it would be x squared, negative x squared. And I'd pass through there. Okay. Okay, it's a exponential decay, which starts out like this, but I'm going to reflect it using that -5, and it'll end up like that, okay? So as I go towards negative infinity, I'm going to go towards negative infinity. As I go towards positive infinity, I'm going to go towards y equals 0. So negative infinity, positive infinity. 0 to 2 pi, including 0, where k equals -1. Sine equaling a half occurs at the pi over 6's. Pi over 6's has the opposite side length, that's a half, with the hypotenuse of 1, the unit triangle. I want the pi over 6's where sine is negative. Sine is negative in the third and the fourth quadrant, so I want this pi over 6 and that pi over 6. So that's those two. Looks like we want to expand, so maybe start by switching the division into subtraction, switching the multiplication into addition, either knowing the log of e to the fourth is just 4, or bring the 4 down knowing the natural log of e is 1. So I have ln 2 plus 4 minus 3 ln x. Okay, vertical asymptotes. This is like easier to do if you just like understand when you have vertical asymptotes versus sketching this function. Vertical asymptotes occur if you have a number over 0. I'm going to just look at this tangent part and understand when this is going to be some number over 0 or 1 over 0. I think about tangent being opposite over adjacent. The y's over the x. I want the adjacent or the x distance to be 0. So I realize I have the pi over 2's. 3 pi over 2. Really, it's pi over 2 plus pi n. Tangent's period is pi, so we don't need both. I just need pi over 2 plus pi n. Those are my angles, but my angles will have to be manipulated, be dilated to get solutions. I'm going to multiply by 4 to get my solutions. 4 times pi over 2 is 2 pi. 4 times pi is 4 pi n. So I have 2 pi plus 4 pi n, where n is an integer. It's probably easier to do that than to try to sketch with the adjustment of your period and doing it that way, though that is possible if you remember how to sketch. Period is pi over b. b is a fourth, so the period is 4 pi. However, there's 4 pi. Halfway in between is 2 pi. We don't go all the way to the across to get to 4 pi. We would have 8 pi here. This would be 6 pi. Tangent of 0 is 0. I mean, I am vertically reflecting it, but you can see here is an asymptote. And then here is a 0. And here is our next asymptote. So 2 pi plus 4 pi. All right, my end behavior is negative infinity, positive infinity, negative infinity, positive infinity, x's, y's, positive infinity, negative infinity. So I have this negative x to the odd. Pay attention, make sure you're going in decreasing order to find the degree. So I got that. Okay, as we get close to 1, but where x's are bigger than 1. First of all, we should know that x equals 1 is a vertical asymptote. This is when you should break out a sign analysis, either a full sign analysis or just a smaller partial sign analysis. If I did a full sign analysis, I know there's a vertical asymptote at 1. There's a 0 at -3. If I plug in something like 5, negative, positive, positive, so this would be negatives. I would switch signs. I have a 0 here. Conversely, if I plug in something like, be careful how far you plug it in, but like 1.01. Negative, positive, positive. Yeah, that's a negative. So your rational function's behavior around this vertical asymptote is going down to negative infinity as I approach 1 from the right, going up towards positive infinity as I approach 1 from the left. As the input values get closer to 1, but for x is bigger than 1, I see I'm going to negative infinity. My output values are decreasing without bound. The limit notation for this is the limit as x approaches 1 from the right of my function is negative infinity. You could also talk about 1 from the left being positive infinity. We have a hole at -3. Holes occur when you have 0 over 0. To find the location of the hole, you think about plugging in values close to -3. You cancel out the values close to 0, and you see what's left. And what's left needs to equal 4. So first things first, I'm going to understand the hole's at -3, not at 3. A is gone. B is in the running. D is in the running. C is gone. So B or D will have a location of the hole that's 4. This is when you think about plugging in stuff close to -3. Now, when I plug in stuff close to -3, I'm getting something close to 0. It's not 0, it's close to 0. I'm getting something close to -7, getting something close to 0, and I'm getting something close to -4. Now, when I cross out those numbers close to 0, I get a number that is close to +7. That's not 4. It's got to be this one, but let's check. If I plug in something close to -3, I get something close to 0, something close to 0. I get something close to -8, and I get something close to -2. These numbers close to 0 cancel. These numbers simplify to be 4, so that's why it's 2. Oh, this is a good one. Shout out, old school. If one of your zeros is complex, you know you have 2 complex solutions. Complex solutions come in pairs. So I know that's going to be 2 factors, 2 minus 3i, or like x minus that, and x minus the other one. Okay, that's 2 factors. So I know I have an x squared coming from complex solutions. I know that I have a real solution that has a multiplicity of 2 because we're just touching and bouncing and not changing sign. I know we have a real solution that has a multiplicity. This is going to be x plus some number. A real solution that has a multiplicity of 1 because it's passing through. So that's going to be x minus a number. So I can see I have 2, 3, 4, 5, x to the 5th power. And that is the least possible degree. Not 3 and not 4. You think it might be 4 because you see 1 zeros that, but complex solutions come in pairs. Okay, you want to do this easily. I do too, but it might actually be easiest because I can't eliminate that many to actually use the rectangular form in SketchUp. Okay, the period is 2 pi over 3. So I got 2 pi over 3 as my end. I'm going to step that out into pi over 6's by dividing by 4. I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. I have radii that start at 0, go to -3, go to 0, go to 3, go to 0. Now, after doing that, I can pick out probably my graph just by some of the points. For example, I'm looking straight here at pi over 2, 3. Sine of 3 times pi over 2, the sine of 3 pi over 2 is -1 times -3, 3. I'm looking for the point pi over 2, 3. That's that one right there. That's why I'm selecting C. I'm also going to make sure it works out by kind of stepping it out. For example, from 0 to pi over 6, my radiuses are negative. I should see graph in the opposite quadrant, starting at pi and going here. Okay, starting at 0, going to -3. Then from pi over 6 to pi over 3, I also see negative radiuses that are decreasing. So that would show up in the opposite quadrant as negative radiuses starting here and decreasing till there. And then from pi over 3 to pi over 2, I have these positive radiuses that are increasing. So from pi over 3 to pi over 2, I see these positive radiuses that are increasing. If you wanted to trace out how the graph is created, it starts at 0, it goes to negative radiuses, the radius then decrease until we get to pi over 3, and then from pi over 3 to pi over 2, we have that. And then from pi over 2 to 2 pi over 3, we go there. So we only just graphed two of the guys over this one period, which is interesting. But that's good. F is odd. What does it mean to be odd? Similar to odd function, odd polynomial y equals x cubed. You have the point 2, 8. You have the point -2, -8. Opposite x's produce opposite y's. Let's see if they have any data kind of with that. No, they're trying to have you figure it out. So opposite x's, opposite y's. Opposite y's, opposite x's. A is -10, B is 4. So added together, you get -6. If there's an even function, opposite x's, same y's, like y equals x squared. All right, let's see if we can reduce some of these choices. Not really. What is the difference? They all have 2, so they all have the period. It's just where do we start? How are we traveling? They all have +2. They all have 4. So it's really, it really is just checking. So it's not A because sine is positive, and then back to 0 negative in the first and second quadrants. So this would be going up, down, up, and that's not right at 0. If I shifted my parent function over to pi over 4, this would be my starting point. However, that is a minimum, so that means I would need to have a -4. So that could be right, but it's not right. If this was a -4, that would be right, but it's not right. If I shift over to pi over 2, I'm here. I can see I'm going up first. So if this was +4, that'd be right, but it's not +4, so it's wrong. So if I go to 3 pi over 4 right here, I can see I'm starting at a max, just like cosine of 0 is the maximum value of cosine 1. So this all checks out. That's a good question. Okay, exponent rules. X squared times x cubed is x to the 2 plus 3. Can you go backwards? 4 to the x plus 2 is 4 to the x times 4 squared. So it's 3 times 4 to the x times 16. Well, 16 times 3 should be 48. Slant asymptote. Divide. Get the equivalent form of the rational function, but it's polynomial plus a remainder, where as x approaches infinity, the remainder disappears. So divide. Now, I'll do it the long way, but I'll also do it the short way. And I'm actually going to show you the short way first because you guys like to copy down what I do first. Short way is using synthetic division. Flip x plus 3 to like x minus 3. Flip the operation you do from subtract to add. Bring down the first thing just because you'll see it ends up coming down. Multiply, add, multiply, add. We don't really care about the remainder because it'll go away. These are my numbers. These are my x's. So I have negative 2x plus 9 minus 35x plus 3's. As x approaches infinity, this goes to 0. My end behavior will be negative 2x plus 9. Let's double check. I need to get rid of the negative 2x squared. I need negative 2x. So that's negative 2x squared minus 6x. Subtract means add the opposite. There's 9x. I need a plus 9. I'm done, but let's just keep going. That's 9x plus 27. Subtract. Bring down the 8. Add the opposite. It's negative 35, just like we suspected. These are the equivalent. This is the equivalent form of the rational function. If I graph this, it's the same as graphing this. For end behavior, as x approaches infinity, this goes away, and this is the exact equation of my end behavior, negative 2x plus 9. Terminal A of the angle intersects circle at point Q. The circle has a radius of 5. Point P is a 3 and a 4. The cosine of theta. Theta goes over here. This has to be negative 3 then, and this has to be 4. And this has to be 5. The cosine, now this is an important thing that we talked about that is taken for granted and sometimes gets confusing if you forget about it. The cosine of an obtuse angle is the exact same as the cosine of the reference angle with the x-axis. So whenever we take an angle, let's say like, I don't know, 5 pi over 3. 5 pi over 3 is this angle 300 degrees. And it's like, what the heck is the cosine of that 300 degree angle? Well, it's the exact same as the cosine of the reference angle in the correct quadrant. So I just need the cosine of that reference angle adjacent over hypotenuse. Wow. I'm sorry. 4, 3. I would have gotten that wrong. I would have gotten that wrong if they had the answer choice. Adjacent or negative 4/5. My bad. Be careful out there. Don't make silly mistakes like Mr. Mester did. A product, x squared cubed, is x to the 2 times 3. X to the 2 times 3, therefore, can be written as x squared cubed. 4 to the negative 2 times x can be written as 4 to the negative 2nd to the x, which can be written as 1 over 4 squared. Don't write that as negative 16. It's 1 over 4 squared to the x. So that's 1/16 to the x. G of 1/9. equals the log base 3 of 1/9. You could just know that this is -2. That's one way. Because you know logarithms, it's all about what is the exponent of the base that gives you this. You could say the log base 3 of 1/9 is something I don't know. How can I reveal its answer? I can take 3 to the power, and now I can see, oh yeah, I need the power of 3 to get -1/9. You could, using exponent rules, rewrite this as the log base 3 of 1/3 squared, which then becomes the log base 3 of 3 to the -2nd. Log base 3 of 3 to the -2nd is -2. 3 different ways to get the same answer. All right, this is good because I'm going to move some stuff around first. I don't like how it's set up. I'm going to subtract log base 7 of 4x plus 6. I'm also going to subtract the -2. Get that out of here. Get that to the other side. I'm going to use log properties to simplify this. Now, since it's not an inequality, I can solve the equation just by kind of like multiplying both sides by the denominator. If it was an inequality, move everything onto the same side. Common denominator, use a sign analysis. So since it isn't, we have log base 7 of x minus 1 over 4x plus 6. That equals -2. I'm going to take 7 to the power of both sides. 7 to the -2nd is not nice. It's 1/49. Ugh. I'm going to multiply both sides by 4x plus 6. There's another way you can do it, but I like this. So I have 1/49 times 4x plus 6. Honestly, this would end up being the other way you do it. Multiply by 49. To get rid of that 1/49. Subtract 4x. Add 49. Divide by 45. Nine. Nine times 6 is 54. 9 times 5 is 45. What is going on? Four x plus 6. X minus 1. Correct. Subtract. Correct. X minus 1. X minus 1. 4x plus 6. Correct. 7 to the power. 7 to the -2nd. 1/49. Good. 4x plus 6. 4x plus 6. X minus 1. Just checking for mistakes here. Like, make sure I did not switch signs on stuff. This is what you should be doing when you encounter a problem. Distribute the 1/49 if you want to. Rather, multiply by 49. I'll show you a different way to do this. Start. That is 49x minus 49. That's correct. I subtract 4x, 45. I add 49. There you go. Silly. There we go. All right. If you're ever not getting the answer, don't assume you did something hugely wrong. Maybe just check. Now, here's another way to do it. Watch this. I'm going to write 2 as the log base 7 of 49. Now, that doesn't mean you can take the log 7 to the power of both sides. You can condense this to be the log base 7 of 49x minus 49 equals the log base 7 of 4x plus 6. This might be easier to do. Rewrite the number as a logarithm. And then you take 7 to both sides. Poof, that's gone. You end up here and then do arithmetic correctly. G of x is 4 to the x plus 1. H of x is 2 to the 3x. When does this equal 1? Well, we end up with 4 to the x plus 1 equals 2 to the 3x. Easiest thing to do is to make the same base. 2 squared is 4. Now, multiply 2 by x plus 1, a power to a power, you get 2 to the 2x plus 2 equals 2 to the 3x. Now you can take the log base 2 of both sides, and you get 2x plus 2 equals 3x. X is 2. Yeah. Guess and check if you're not sure what to do. 2 to the 6th, 4 cubed, 2, 4, 8, 16, 32, 64, 4, 16, 64. Guess and check could work too. Okay, your outputs are increasing at a constant rate. There's a linear increase versus your inputs are proportional. They have a common ratio. This is a logarithmic function. It's the inverse of an exponential function. That would be flip-flopped. So logarithmic function, the input values change proportionally as the output values increase in equal lengths. Inputs, outputs. We had this on our homework. How do I graph cosecant? I start with graphing sine. If I graph sine, I will know the y values that I will go up to. Then I will think about what happens if you flip or take the reciprocal of those y values. Many of you forgot this. Sine, and for the range, the y values, you don't have to worry about the period. So I don't really care about the 4. I just care about the 2. I'm just going to say I go up to 2, I go down to negative 2. Sine goes up, down, up. Now here's the deal. Whenever you flip these y values, but thinking about them as the parent function, flip 1, it's 1. Flip negative 1, it's negative 1. Flip 0, it's like 1 over 0 becomes a vertical asymptote, undefined. Flip a value close to 0. Flip like 1/1000th, 10th, 100th, thousandths. It becomes 1,000. So this is why the graph looks like this. Flip this positive decimal, take the reciprocal, it becomes a big number. Flip positive values or negative values, negative 0.001, it becomes negative 1,000. So we want the y's that are bigger than 2 and the y's that are less than negative 2. These are the y's bigger than 2. These are the y's less than negative 2. Yeah, I did not have to do all that work to get that answer. All right, last question of the no calculator part 3. Plus 2e to the negative x. Guys, this is the same as when do these two graphs intersect? Solve the equation. Subtracted 3 divided by 2. I took the natural log of both sides. I then took the opposite of both sides. All right, part 1 done.